once again, and this is your online mathematics tutor, Comfort Amoako-Attah. Thank you so much for joining me this time around too. And I believe you are happy going to learn mathematics, and that is great. So today we are going to apply so many things in solving trigonometry. So come along with me, pick your joters as you join me solve these questions together. So the first question we have here is, given that tan theta is 2/3, find sin theta and cos theta. So in this case, you've been given tan theta to be 2/3. So how do we use it to solve or to find sin theta and cos theta? So we first of all have to draw a right angle triangle. Then we fix in our theta. So after fixing our theta, we locate where our 2/3 is. Tan means what? 2. Don't forget it. There are some little ways of remembering things. So we have something called the so means sine, which is opposite over hypotenuse. The ka means cos, which is adjacent over what? Hypotenuse. Then the TOA. The TOA means tan, which is opposite over adjacent. So if you know this one in mind, you can solve so many examples. Good. This is tan theta. So tan is what? 2. Opposite over adjacent. Then you get your opposite when you have your angle in your right angle triangle. So in this case, we are positioning our angle here. So where do you think our opposites will be? Our opposites will be this side, because the angle is directly opposite to this side. So this will be our 2. Then adjacent is what? This place. The longest side becomes our hypotenuse. So after positioning our numbers, the question now is find sin theta and cos theta. Sin is what? So which is opposite over hypotenuse. But the hypotenuse is not given. So you have to use something called the Pythagoras theory to find the hypotenuse. So let's do it together. So let's say this side is A. Let's represent it with a variable. So after representing with a variable, we now apply our Pythagoras theory. Okay, so using the Pythagoras theory, we can say that the Pythagoras theory, we know it. The square of the hypotenuse is equal to the sum of the square of the two opposite sides. So we have the hypotenuse to be a square. Good. Then the sum of the square of the two opposite sides, which is 2 squared plus 3 squared. Great. So this becomes a squared equals what? 4 plus 9. Then we have what? 13. We are looking for a and not a square. So what do? We have to square root both sides. So we square root this side, then we square root the other side, so that the square will cancel out our square roots over here. So therefore we can say a is equal to square root of 13. So we can now fix a to the square root of 13. Then we come to our main question. So we should find, first one is what? Sin theta. Good. So what is sin theta? Sin theta is what? Opposite over hypotenuse. The angle is here, and the angle is opposite to the 2 and the hypotenuse. So it becomes 2 over square root of what? 13. Good. theta, that is adjacent over hypotenuse. Cos theta, adjacent over hypotenuse. So what is our adjacent? Our adjacent is here, and where is our hypotenuse? It's over here. So it becomes 3 over square root of 13. So that is that for this question. Let's solve one more examples under the same topic. Okay, so in this case, I'm going to give you sine theta. So given that sine theta is 3 over 5. Okay, so we have given that sine theta is 3 over 5, which use this to find our cos theta and tan theta. So how do we solve it? We first of all have to represent it on our right angle triangle. So this time around, I'm positioning the theta over here. So where do you think our opposites will be? Sine is good. So it's opposite over hypotenuse. So this is opposite, directly opposite to this side. So this will be my opposite. Then hypotenuse will come as what? This side. So we have to find our adjacent because cos is what? Adjacent over hypotenuse. Good. So we are going to apply the same Pythagoras theory to solve for this side. So I believe you know the Pythagoras theory now. That is, the square of the hypotenuse is equal to the sum of the square of the two opposite sides. Good. So we have 5 squared equals a squared plus 3 squared. We are looking for a. So what do? We have to group like terms. So this becomes a squared equals 5 squared minus 3 squared. So this becomes a squared equals 25 minus what? 9. And what is 25 minus 9? 16. Good. So a squared is equal to 16. We are looking for a. So what do? We have to square root both sides of the equation. Good. So this becomes a is equal to 4 units. Okay? Alright, so this side means our a is giving us 4 now. Then